Hello everyone, I hope you are doing exceptionally well. In this video, I want to talk about Python object-oriented programming, specifically the use of classes in Python, and giving you a pretty relatable example of how to use it in your code. Now, object-oriented programming is really useful not just for data analysis and machine learning and all of that, but also for making apps, making games, making programs that require users to create profiles, entering information that is stored, and maybe there are differences and similarities between the different users. Now, OOP, or object-oriented programming, is just a method of structuring a program by bundling or collecting properties and behaviors that may be related or are completely unique, and turning them into individual objects to be called upon. Now, these objects have what you call attributes and methods. Attributes are characteristics, and methods are what the object actually does, quote unquote, physically. Now, the reason why OOP is so good is because it allows you to make potentially complex programs a lot simpler by programming different behaviors to different objects and allowing many different objects to access those behaviors and attributes, and they all work at the same time, rather than what I used to do when I learned Python many years ago, just write more and more complex functions and having no way to really transfer data between the functions or transfer memory between the functions. So it was, OOP definitely solves that. So in this picture, here's just a quick example. So I can create a class called animal. Now, animals, they have two attributes and two methods that I'm keeping very simple. The first two attributes are the name of the animal and the age of the animal, and some of the methods are that they eat and sleep. Now, what if I wanted to code a cat, a dog, and a rabbit? I can't keep adding more methods to the animal or more attributes to the animal and making sort of if-else statements or Boolean statements to check whether it's a dog or a cat or a rabbit. What I can do instead is that I can just inherit from the animal class and create a cat and a dog and a rabbit from it, which have unique attributes and methods. Now, in the cat, in dog, and rabbit, I just go with unique methods. So cats inherit the attributes and methods of name, age, eat, and sleep from animal, but they meow. Okay? Dogs do the same thing, but they bark. Rabbits do the same thing, but they hop. If I wanted to create unique attributes, I could say cats have prehensile tails, dogs have canine teeth as an attribute, and rabbits have long ears, or something like that. Right? So this is a very simple example of class or OOP in Python. So we're going to head into the main part of this tutorial, and which is the programming of the Darktide game. See you there. Right now, there are 4 classes in this game. There's the veteran Sharpshooter, there's the zealot preacher, there's the psychokinetic, and there is the Ogryn skullbreaker. Now, each of these classes have the same parent attributes. They can all run, walk, they can all melee, they can all do ranged attacks, and they all have health and toughness. Toughness in this game is similar to shields, right? It helps prevent and mitigate damage. Now, in the Zealot Preacher's case, the Zealot Preacher has an ability called Chastise the Wicked, where he or she charges forward, does a critical hit, and also regenerates 50% of their maximum toughness in that move. Whereas something like the veteran Sharpshooter has a different type of ability called Volley Fire, where he maintains a stance, and he highlights all the enemies on the map or within the vicinity, and he gets increased range damage for that duration. So what I'm going to do is that I'm going to create a turn-based game, an automatic turn-based game that takes the Zealot Preacher and the veteran Sharpshooter and puts them in a team versus some enemies that I'm also going to create. And we are going to see how their attributes and how their methods, what they do, helps them win or lose the game. Okay? So I've already programmed this before, so I'm not going to do everything from scratch. However, it will be a sort of code along with me explaining exactly why I'm doing what I'm doing. So the first thing I'm going to do is that I'm going to create the ability to color the terminal, right? Using ANSI escape codes, right? So create the ability to color the terminal using ANSI escape codes. Okay, and basically I'm going to just make a class and call that colors, and all I'm effectively going to do is create 4 different colors: red, green, blue, and black. And depending on what's happening on the screen, so maybe if someone has attacked, or if someone has regenerated, or if I'm just checking the stats of everything, it will color them differently. It just makes the terminal a bit prettier, right? So I'm gonna have green, and the coding, you can find this on the internet. Just type in ANSI escape code and you can get a whole bunch of different colors. So this is the one for green. And all I'm going to do is just copy and paste this 3 times and change the number slightly. So 31, 34, and 30. And then that is going to be red, blue, and black. And we will use these later. Okay, so those are my ANSI, that's my ability to make colors, right? The next thing I'm going to do is that I'm going to import the modules which I'm going to be using liberally throughout the program. The first module is random. Now the reason why I'm using random is two reasons, right? So this is a turn-based strategy game that operates automatically. However, I still need to introduce the mechanics of randomness into it, mainly by critical hits, right? So in the game Darktide, you have an attribute called critical hit or critical hit multiplier, whatever. Now, from working in industry and still working in industry, there's a concept called MVP, right? Which is minimum viable product. If you are given a project that's over the course of 3 months, the expectation is that every month you will have some deliverable or some feature to deliver that basically meets the minimum requirements of what the stakeholder wants. Now, in this program, I want to show off why classes are useful, and I want to show off a game that works, right? That's all I care about. I don't really care about how complex or how true to the identity of Darktide I'm staying. I just want to show that, hey, I've got 2 classes, they attack each other, and they do this and they do that, okay? So the way I did critical hits was that I'm just doing a random number generator, and it's like every time they attack, a dice is thrown, a dice is rolled, and the dice may roll on a low multiplier or a high multiplier, and that will affect how much damage they do when they eventually attack. So that's why I'm using random. The second reason why I'm using random is because this is a turn-based strategy game that is not operated by the user, it's operated by the computer. So the computer needs to choose which methods, randomize which methods to use. So you're going to see me use random choice down the line when the allies or enemies decide what move to use, okay? Now, in terms of choosing the methods at random, this is the reason why I'm importing inspect. Inspect allows us to look at the class and look and list, basically make a list of all the attributes and all of the methods inside the actual class, right? And I'm specifically using inspect so that I can make a list of that character's methods depending on what class he or she is in, and then the computer can basically randomize which method to use in the attack or in the move, sorry. Okay, so that's that. So these are my modules to import, and I'm going to comment that. So modules to import. Okay, get some space. Okay, so the first thing that I'm going to do after this is I'm going to make the parent class. Okay, now the parent class is simply character. Now, as I said, in Darktide, whether you're an enemy or whether you're an ally, and if you're an ally or enemy, whatever enemy you are, whether you're a Plague Ogryn or whether you're a Dreg or whether you're a Scab, Shooter or Mauler, or whether you're an ally and you're a veteran Sharpshooter, whatever the case may be, you all have shared attributes and methods. You can attack, you can range attack, melee attack, you can retreat to regenerate health, you can regenerate toughness, you could do a whole bunch of things, right? So this parent class basically allows us to make a template. Okay, this is basically a template. So I create a class character and I instantiate the class using this init method, right? And using self basically represents or references the instance of the class, and you will see that along the line I have another method. I have methods that will eventually use some of these attributes, and you will see some lines of code where I do self dot whatever method, and that basically allows me to use that not self dot method but self dot attribute, and that basically allows me to use those attributes as variables in my method. Okay, so everyone has a name, and there's no fixed value for name. So this is not a standard. There's no argument for name. Okay, so when I create a class, I can call it whatever they want, right? However, with health and max health, I'm going to have to make child classes which change the numbers, because not every character is going to have the same amount of toughness or health. Otherwise, they would be homogeneous, and we don't want that. Okay. So I may actually skip through some of this tedious typing. Now here's where it gets important, and as to why you'll see why I'm using random. So for melee attacks, what I did was that I created two attributes called melee lower and melee upper. Now these are the only numbers which are integers. The reason why I'm swapping between integers and floats is because when I used all integers the last time, I coded this and just tested it out. I was getting really weird values and I didn't like it. So just to stay on the safe side, with my high rolls and low rolls, I'm just sticking to integer numbers. So melee lower and melee upper, obviously I've just put one here because this is the parent class, right? But no one's going to actually be the parent class. They're going to be child classes. The veteran Sharpshooter may be bad at melee, so he'll have melee lower 1 and melee upper 2, right? So he can't really high roll, right? He either just doubles his attack if he happens to get a critical hit. But something like the Zealot, right, which is a very melee focused class, they may have poor ranged low rolls and high rolls, but very high rolls on the melee, right? So with melee, may be between 2 and 5 or something crazy like that, right? So melee lower, melee upper, and then range lower and ranged upper. And you'll see how I code these in random. Okay. Now AP in the Warhammer universe, AP is basically the currency that allows characters to do things, right? Ability power. I think the standard ability power is 3. But depending on what game you're playing, you can have ability power of 2 or 4 or 5, and characters can make multiple moves per turn in that same turn. I've just set mine to 3, and you will see how basically anytime a character does a move, they lose ability power, and when every character gets to 0 ability power, the game checks, says, okay, everybody's used up all their moves. Time to refresh everybody's moves and go to the next turn. Okay, so this is my decorator for my initialization function, and now what I'm going to do is that I'm basically going to reference or give myself the ability to reference the attributes that I just did. So guys, don't forget to pause the video, because I'm going to be chopping up the video and skipping ahead when it gets to tedious parts of coding like this, right? All right, so that is the init method. Now, the first proper method, the first useful method that actually creates behavior in the characters is the melee attack, right? Now, self basically references the character actually doing it, and then target is going to represent the recipient of the attack, right? Now the first thing I'm going to do is that, because I've just talked about ability power, Ability power is the ability to make a move, right? You need positive ability power in order to do anything. So the first thing I'm going to do is that I'm going to use some if-else checks to check if they have ability power. So I'm going to say if self.ap, so this is me referencing the attribute AP. If self.ap is more than 0, so if it's more than 0, clearly you have 1 or more ability power, then, you know, do something. Okay, so I can actually make the attack do something. Else, you must be less than 0. That means you don't have any ability power. So I'm gonna print an F string. And what did I write here? I said something has no ability power or action points. Okay, I wrote self.name. So F strings allows us to basically call variables within a print function without having to use formatting. So self.name has no action points, and that basically tells us, hey, you can't, he or her can't make a move. Now I'm gonna change the color, and I'm gonna say that colors.blue. So this is me referencing the class and therefore, and also the method or attribute. I think this is an attribute in that class. And okay, I need to make sure yep. And that allows me to change that terminal to blue, or that printout to blue. So blue is going to be about ability power. Red is going to be whenever something has taken damage. Black is just whatever, and I think green is stats. So if you want to see the updated health, toughness values for everyone, right? So that's going to be my convention, right? So far I've done a simple if-else statement that checks whether the character about to do the attack even has any ability power. All right, cool. So if they do end up having some ability power, I'm going to make a variable called melee damage, and this is basically me calculating how much damage the self is going to inflict or attempt to inflict on the target. And it's going to be self.damage. So this is me referencing the attribute damage here, which for the parent class is just 10, but for the child classes will be different values. Multiplied by random, so I'm referencing the module random. Randint, which should be a method in this class random or module random. So randint, and then I'm going to choose my lower bound and upper bound. Because this is melee attack, I'm going to use ML as my lower bound and MU as my upper bound. So it will choose a number between 1 and whatever, and multiply that onto the damage, and that will be the melee damage that the self will inflict, or attempt to inflict rather. Cool. So now we need to talk about toughness. Now toughness is damage mitigation, right? There's a mechanic in Darktide which says that if you are hit with a melee attack, toughness will prevent that melee attack. However, if you have 100% toughness at that time, you will only take damage to toughness. However, if you have less than 100% toughness at that time, you will take a certain percentage of the incoming melee damage to your health. Now, that's fair because, you know, for something to melee attack, they need to get within range. They need to put themselves in danger in order to make that melee attack. It's not the same with range attack. Ranged attacks have to go through toughness before they go through health. Now, I made a mistake because I wasn't sure whether or not having 100% toughness basically made you immune to health damage. What I did was that I ended up putting a scale on it, whereas if you had 100% toughness, you only took 10% of the incoming damage to your health. So that was the way I coded it. I want to leave it like that because, you know, I can't be bothered to change it. So we check if the target has toughness. So target, referencing the toughness of the target. If the target's toughness is more than 0, then we make another variable called get toughness, right? Now I'm thinking, okay, how do I calculate how much damage gets through the toughness and how much is left over to target the health, right? So what I did was that I calculated get toughness, and get toughness basically equals the target toughness take away the incoming melee damage, right? Because we know that the melee damage has to eat through any toughness first. All right, now what I did was that I had some if else. If get toughness happens to be more than 0, right? That means they have toughness left over. That means all the shields, all the toughness just eats up all the melee damage. So if get toughness is more than 0 at the end of this calculation, then we do target health. So this is me saying that no matter how much toughness you have, you will always take some form of health damage if they melee you, right? So target health is going to be subtracted using this formula right here. And this is where my scaling came in, right? So 90% and then target toughness. So it's going to be a percentage of the maximum toughness. And then I'm going to reduce the incoming melee damage by that amount, okay? So reduce the target health by this line of code here. So the more toughness you have, the less damage you would take to your health, which is fair, right? If you're basically at 100% toughness, then this will only say take 10% of the incoming melee damage to your health. However, the less toughness you have, which makes sense, the weaker you are. So your damage is actually gonna be a lot higher to your maximum health. Sorry, to your health at the time. All right, cool. And then I'm also going to reduce the toughness, right? I'm going to reduce the toughness after the health. I don't want to reduce the toughness before the health, otherwise it might mess up my health calculations. And it did. That's why I've got the toughness calculation. I've got this toughness calculation subtraction afterwards. Okay? Melee damage. And then some terminal code. So colors dot red plus an f string, and I wrote self dot name just attacked f string target dot name for self dot damage. Actually that's wrong. I just want melee damage actually. Yeah, points of damage. Close string. Okay, so that's our primary. This is going to be our primary melee damage calculator, right? What I'm also going to write is that I'm going to put self AP. So after this is done, self AP take away 1, right? Because I want to reduce the ability power of a character after they have done a move. Now, I'm going to have else. So if the toughness is less than 0, then that means they take damage directly to their health. Okay? So if the toughness is 0 or less than, it can't be less than, but if the toughness is basically 0, they take damage directly to their health. So we calculate get health. Get health equals melee damage take away target toughness and we write target dot toughness equals 0. So a bit of an explanation of why I'm doing this, right? So if the target happens to damage past the shield, this is what I'm calculating. So if get toughness is less than 0 at the end of the incoming damage, then that means the damage was big enough to get past the shield, right? So then I have to take away the target's toughness away from the melee damage, and the leftover melee damage, that immediately subtracts from the health. All right. So I set, after I calculate this, after I calculate get health, So this is going to be the damage that goes straight to health. I'm then going to do target dot health subtracted get health, I believe. Yes, get health. All right, and then I'm just going to copy and paste this line here. And this is the beautiful thing about Python, you know, just if your logic makes sense, then you can just copy and paste. Now, again, MVP, there's probably a better way to write all this, but I'm not bothered. I just want to have something that works, and then if I ever get commissioned to make a game, I'll obviously clean it up. Okay. All right, and then the other thing that I want to write as well, right? That what if the incoming damage is so big that the target's health just gets reduced completely to 0? So what I did as well is that if target health ends up being less than 0, then set target health to 0. Target health equals 0, and this avoids the funky negative health problems, right? Okay, else right here. So I've got it on. So if target toughness is more than 0, do all of this, and then I've got a couple of other if statements. Else, if the target toughness is basically not more than 0, they immediately take health damage. Else, do all of this. Well, don't do all of that, but actually, what did I write? Target health just immediately gets blasted by the melee damage, like so. So melee damage. The target health immediately gets blasted by the melee damage, and this is all kosher. Okay, right. So this makes sense to me. Cool. Okay, so that's our melee attack. Now I promise you that this is the hardest part of the code, or this is the longest part of the code. With everything else, we can basically copy and paste with minor alterations to the lines of code, right? So for example, for ranged attack, and notice in the range damage, there's no extra calculation that tries to minimize the melee damage, but also attach it to the health, right? With range damage, you have to always get through the toughness before you actually start making health damage, right? So this is the hardest part about the code that I foresaw, because there were a lot of calculations to do. Okay, cool. Now I'm going to add a couple more methods, and these methods were just being added at my leisure. Okay, they may not even be in Warhammer. I just thought that they were interesting. So def regen toughness. So at the end of every round, everyone needs to regen some form of toughness, right? And I've just done a simple calculation. I've just said that self toughness plus equals 20% of their maximum toughness. So self dot max toughness. And then I've said if self toughness, after this calculation is done, if self toughness happens to be more than self dot max toughness, then don't do that nonsense. Instead, set self toughness equal to self max toughness. And that is basically my get out of jail free card to not have numbers that are higher than the maxes that I've set or that are lower than 0. Okay, so you'll see, I think you'll see a bit more of this down the line, right? So this is basically me. If I'm playing Zealot and I've taken too much damage, I step back, I go back towards my team, and I regenerate some toughness. Okay, so this is what regen toughness basically is. Another method is def reset AP. Now, the characters won't be doing this themselves. I'll code it so that they won't be doing this themselves. Okay, and all I'm going to do, at the end of every round, the computer will check whether or not everyone has 0 AP. If yes, so if true, then everyone gets this. Everyone resets AP and the new round begins. Okay, again, I haven't coded that yet. You'll see it in due time. So colors, am I spelling colors correctly? Colors dot blue plus an f string. Okay, maybe not an f string. Refreshing action points, and then self.ap automatically goes back to 3, just like what we instantiated before. Okay. Everyone has a display stats method. So display stats, and this is going to be self as well. And this is going to be print and then colors dot green plus f string, and current self dot name stats, / and n. So I want health, and that's going to be self dot health, and then / toughness. That should be toughness. Yeah, toughness, and that's going to be self dot toughness at the time. And last but not least, action points as well. How many action points that they have? I'm just wondering, is it possible to do this? Action points and self.ap, and obviously close with the quotations. Okay. Now I'm just gonna. Does that work? Oh, doesn't work. Okay. I need to basically go off the screen right there. Okay, so everything seems pretty kosher for now. Now here is where we basically use the inspect method, right? So every character is going to have a method called choose action, and this is going to allow them to basically choose their own actions randomly. Okay, so what I've done here is that I've written a line of code that basically allows me to view all of the methods inside a particular class or member of that class. So I've done all methods equals inspect.getMembers, and this was the easiest way for me that I knew how to, Google. Predicate equals inspect.method. Is method rather. And what I've done is that I've basically using this particular variable or object. This is an object. I don't know what object this is, but this is an object. Now what I want to do is that from that object I want to create a list of all the methods that are available. So what I've done is that I've created a list and I filled it using comprehension. Method, the first item for method in all methods, if the first item is not equal to the following methods. So I want the computer to be able to choose the methods for me, but they can't choose this again. They can't choose that. They can't choose this, and they can't choose the init method. Otherwise, they're going to be initial. I can't even imagine what will happen. They will try to initialize themselves again, which is what I don't want. I just want them to choose what they would do in a game. So they might decide to fall back and regen toughness. They might decide to do a range attack. They might decide to do a melee attack. And when we go to creating the child classes, they might, if it's a zealot, they might decide to chastise the wicked. If they're a veteran sharpshooter, they might decide to volley fire. If they're a Plague Ogryn, they might do disease cloud. I made that up. plague disease. So I'm going to choose some methods that can't be in this list. Cool, right? Then the random action chosen is going to be random choice, yeah. Random dot choice and then method. Oops, method. So it's going to pick a so this list has all the methods of that particular class with the exception of the ones that I've written here. And then this random action will choose one of those methods at random. And then I will print colors dot green plus f string, and then the character making the move self dot name chose random action to do. Okay, and then this get attribute here allows us to basically retrieve a method from the object and call out the method whilst passing in the attributes of both the self and the target without having to do some weird extra lines of code. So this was something again that I googled because I was getting errors where my character would choose an action but it wouldn't be able to reference the target's attributes or its own attributes in order to deliver that movement properly, right? So self and then random action and then target. Okay, so whatever random action, if it has a target involved, then the target's attributes will also be referenced as well. Okay, great. Okay, so we've created our parent class and it's smooth sailing from here. So what we're going to do now is that we are going to make three child classes. One is going to be the zealot, the second one is going to be the sharpshooter, and the third one is going to be the Plague Ogryn. Okay, so making the child class Sharpshooter. So because I am going to change some of the attributes, and because I'm going to add my own methods or extra methods to the child classes, I decided to use super. Okay, so super is a kind of decorator, which basically means that you have to reinitialize, but you can use the same initialization attributes of the parent class, but if you want to update them however you want, you can, right? So again, we are going to use the same decorator here. So I'm just going to copy and paste. I'm just going to copy and paste all of this. I'm just going to copy and paste all of this, and you'll see the minor changes that I will make. So class sharpshooter, which is inheriting from the character class, right? And then I'm doing the same initialization, but I'm going to make some changes. So the sharpshooter has 150 health and 200 toughness. Now, the damage of the sharpshooter is still 10, but the melee damage, he low rolls for 2 and high rolls for 3. So that's not very exciting. But the range damage, because he's a sharpshooter, he low rolls for 2, but he high rolls for 4. And of course he has AP equal to 3. Now, I'm going to add an extra decorator here, which is called super. Okay, so super, and then I'm going to reinitialize my name. So name, health, max health, toughness, max toughness, damage, ML, MU, RL, RU, and AP. Now, probably someone who's a better Python programmer than me is probably going to see this and say, hey, you don't really need to use super. You can just reference directly the character and when you're instantiating the class, you can just add in your own healths, own numericals for health and whatnot, and you can still add in new methods. Fair enough. I'll leave that up to when it happens, basically. All right. So I'm only gonna add 2 extra methods. I've done something wrong. This is, yes, okay. Are they properly indented? Okay, so that works. Okay, cool. So I'm only going to add 2. Okay, something is weird here. Reset. Okay, so that's what it's called, reset. So everything has reset. I just forgot to write it down. I was wondering, where is it? So I forgot one method, which is called reset. And self target does nothing to the target, to be honest. So if self AP, so again, the same sort of program here, if self.ap is more than 0, then do something. Else print has no action points, okay? So if self.ap is more than 0, then self.health plus equals 20. And then if self.health happens to be more than, if self.health happens to be more than self.max health, then obviously do the good Lord's work and set self.health to equal self.max health, so that we don't get some weird behavior. And then take away AP by 1. Great. Okay, that should work. Okay, so back to the sharpshooter. I'm only going to add 1 extra method, and that's going to be the volifier. So volifier self target. Now the easy way for me to program this was to basically feed off of the ranged attack, right? Now I had to add something extra because when you do a ranged attack, you lose AP. So what I wanted to do was that anytime the volifier calls upon the ranged attack method, but it adds AP so they can spend AP, so that I don't end up with negative AP. If he ends up volley firing like 5 times, he'll have negative 5 AP, which is silly. So what I did was that I just did this. So if self.ap is more than 1, so there's a criteria for there to be volifier, right? There's a criteria for there to be volifier. The sharpshooter must have at least 2 AP, because volifier is, if volifier high rolls, that's a lot of damage, right? So if self AP is more than 1, then x equals random.randint between 2 and 5. So for I in range x, so let's say x falls on 5. For I in range x, self AP plus equals 1, and then print volifier, so in red, so colors dot red plus volifier, right? And then self dot range, what's the method called again? Ranged attack target. So the sharpshooter is gonna do a ranged attack by however many times x ended up being. So if x falls on 5, it would do this method 5 times. So you can imagine by the end of 5, you're negative. By the end of 5 moves, you're negative 5 AP. So that's why I'm adding plus 1 AP down here, right? And then at the end, I'm going to set self AP to 1. Now this is easy because the Sharpshooter has a maximum of 3 AP, and he needs a minimum of 2 AP in order to do this. So that means that if he had 3 AP, then if Volifier was the first action that he chose, then he should have 1 AP. If Volifier was the second action that he chose, he would have 2 AP, and then he would have 0 AP. So I actually need to do something. I actually need to add some code here. So if self AP is more than 2, then set self AP equal to 1. Elif, if self AP happens to be more than 1, then set self AP equal to 0. And then, did I space them out? I did, okay. And then else, he does not have enough. Okay, so no action points. Else print not enough action points. I just want to check if this is correct. So if he has 1, then I need to print needs at least 2 action points, and I believe this should work. So if he's got 3 action points, he ends up with 1. If he's got 2 action points, no, I should do this. If self.ap is the same thing as 3, and the self.ap is the same thing as 2, and anything other than that, he doesn't have enough action points. Okay, that makes sense to me. All right, cool. So the next class to make is the child class Zealot, well, Preacher, the Zealot Preacher. Okay, and I'm just gonna copy and paste this because there's no need. Work smarter, not harder. Now the Preacher has a lot of health, so 200 health. To be honest, I think I should put more, but how much? 150. So I should really put that to. Should really put that to 125. To be honest, put that to 125. Cool. Anyway, 200 health, but only 100 max toughness, which is very strange for a class that has to be in your face. Now, the melee lower and the melee upper that I've got is 2 and 6. So if the Zealot high rolls, he will do a lot of damage. However, the range up and low is really boring. Okay, and again, I've got my super here, just like I had it with the Sharpshooter. Cool. Now, what I'm going to do is that I'm only going to add one extra method, and this is called Chastise the Wicked. So when the Zealot charges, regenerates 50% of his maximum toughness and does a melee attack. Okay, so if self.ap is more than 0, then self toughness plus equals 0.5 times self max toughness, and then if self toughness at the end of this calculation happens to be more than self max toughness, self toughness simply equals self max toughness. And we print some stuff. So print colors dot green, because it's stat related, so green is stats related, and then self dot name we generated a certain amount of toughness. So 0.5 times max toughness. I didn't bother making it its own variable because that would have self.max toughness actually. I didn't bother making it its own variable because that's just extra coding memory that I don't need. Okay, there we go. And then what we do next is that we self.melee attack the target. Now, I'm sure there's something that I can do that can cause it to definitely high roll on maybe a 5 or 6. But again, MVP. I just want it to melee. Hopefully it high rolls on a 6 and then he crits. If he doesn't, oh well. He still regenerated some sustain. Okay. So again, MVP. I'm not trying to make the perfect game. I'm trying to make a game. Else, print. You have no ability points. Has no action points. Okay, very good, very good. Okay, last but not least, I need to make a Plague Ogryn class, right? And again, I use the same kind of decorators. So Plague Ogryn. So this is one of the big bosses or the boss monsters inside the game. Now it has a max health of 500. It has 0 toughness, so the enemies in this game don't have anything to do with toughness. It has a damage profile of 35. It has a melee lower of 2 and a melee upper of 6, which hurts, but it got a range lower of 1 and a range upper of 4. I'm going to change that to a 3 because that's quite a bit of damage, and it's a bit OP. Alright. I'm just going to copy and paste all of this because I don't want to type it all out again. I don't need to. Again, work harder, not smarter. I'm going to give it just one extra method called Disease Cloud. And this spell, or this ability, when it hits the target, it ignores the toughness and goes directly to health. It attacks 25% of health, right? So I'm going to do, well, 20%. Let me do 20%. Colors.red and then plus the F string. So self.name, so this is going to reference the Plague Ogryn, used Disease Cloud on the target. So whether that's going to be the Zealot Creature or the Veteran Sharpshooter. Okay. And then the target's health gets reduced by 20% of their max health. Healthy. Alright. Whoops, that's, yeah, cool. Whoops, stay on page. Okay, cool. We're almost at the end, okay? Now, what I'm gonna do is that, oh, by the way, just so that you can see, let me just run everything so that everything just makes sense. So what I'm going to do, just to show you this line in action. So what I'm going to do is that I'm going to get that. Can I do this? Plague Ogryn. I don't think I can do that. Seems I can. Okay, all methods. Because I haven't actually made anything from it yet. Okay, I'll do this later. Alright, so what I'm going to do is that I am going to start actually making instances of these classes. Okay, I'm going to make an instance of the Sharpshooter, which inherits from character. I'm going to make an instance of the Preacher, which also inherits from character. And I'm going to make an instance of the Plague Ogryn, which again inherits from character. Okay, so what I have here, I've got a Sharpshooter called Rogue. And notice how I'm entering the name, because the name is the only thing which doesn't have an argument, right? So I need to make the argument for it. it doesn't have a set argument, so I need to give it the argument. I'm going to make a sharpshooter called Rogue. I'm going to make a zealot called Scourge. I'm going to make a Plague Ogryn. I'm going to make a Plague Ogryn called Plague Ogryn. Plague Ogryn. Okay. Last but not least, I'm going to make a random character. So basically, just going straight for the parent class. So Dreg equals character, but this time I am going to change some of these fields, right? So I'm going to do name equals Dreg Gunner. Name equals Dreg Gunner. Health is pretty modest at 200. The max health is obviously going to be 200. 0 toughness because it's an enemy. Enemies in this game don't have toughness. So therefore the max toughness is also 0. And it's, by the way, it's habit that I put spaces. It's habit that I put spaces after everything that I write in coding. Just looks nicer to me, personally. Damage is 16, and its melee lower is 2, and its melee upper is 4. Its ranged lower is 2, and its ranged upper is 4. So it's a pretty balanced enemy unit. The last thing I'm going to do before I actually make the game is make a list of allies. So the ally is going to be Rogue and Scourge, and the enemy is going to be equal to a list with Plague Ogryn and the Dreg. Cool. Spelled that wrong. Spelled that wrong. Cool. Now, what I'm going to do here is that I'm just going to show you why this thing works, right? So let's have a look at Rogue. So we can see here that this basically gives me, actually let me find out what the type is. So it's a list. Okay, so that gives me a list of all of the methods. That gives me a list of all of the methods available to the Sharpshooter. Okay, and notice how it says right here that volley fire is actually specific to the child's Sharpshooter, but all of the rest, like reset AP, reset regen toughness, etc., are methods of the parent character class. Okay, and I'm pretty sure that there's I don't know, maybe it's attributes. It will list attributes. It doesn't, so I'll need to find out what that is. I was just guessing, but this is the way in which I was able to make this list of methods, and then using random.choice pick a random method out of the list in order for the character to do. Cool. All right. Now we make the game. Okay, so round equals 1. So first round. So while true. While true basically means run forever, unless something is false. Okay. So I'm gonna have print f-string round. So it will print the round number and tell us what round we are on. Okay, so the first thing I did was create lists of the health and toughness, because at the end of every action, I want to basically print out the current health and toughness of everyone, so that I know who's about to die or who's nowhere near dying, right? So what I've done is done health. Don't ask me why I called it health 0. I just called it health 0. So health 0 is character dot health for, so this is comprehension, for character in ally plus enemy, right? So this is a very rough way of doing things, because I haven't, within this list, I'm not given the opportunity. I could maybe make a dictionary or something, not too sure, I probably could, but I haven't exactly said what index is what. So without knowing this, so all this line of code does is that it just adds the list together. It just sums the list, it just combines the list together. So Rogue, Scourge just gets stuck straight onto Plague and Dreg. So the new list is going to be Rogue, Scourge, Plague Ogryn, and Dreg. So because I know this, and because you now know this isn't that big of a problem. But if I actually made a game, I would have to code a way to print out the names as well, and I haven't done that here. Okay, I did the same thing with toughness. So I'm just going to copy and paste this and call this instead toughness 0, and character.toughness for character in ally.enemy. And this is pretty powerful, because this allows me to reference the attributes of every person that I instantiated without having to call their names directly, because character is basically, you know, their name, right? This is just a for loop in comprehension form. All right. Now what I want to do is that I want to print their current health and toughness in black. So all health values, just print the list like so. Right, is that what I did? That's what I did, okay. And then do the same thing for the toughness. Toughness 0. Okay, now if the number 0 is anywhere in health, if the number 0 is in health, that means someone has died and I need to stop the game. Again, MVP. I don't need everybody to die or one team to win. I just need someone to die, and then the game ends, and that's my base game, okay? I can make it complex another time. So print, is that indented properly? Print someone has died, and then immediately break the while loop. End the game. So print someone has died, game over. And end the while loop, okay? Cool. Now I need to start coding what the allies do and what the enemies do. So for character in ally, character.choose action. So I'm referencing whoever is an ally and I'm calling one of their methods, and then choose a random enemy. So random.choice enemy. So this is basically target, right? So remember, in choose action, there was self and there's target. Self always needs to be there because it's yourself, as in the character, that is committing that movement. So self is always going to be there. But the target, we need to tell it what target it is. Now I could be like, okay, everybody just attack the Plague Ogryn. So I can write Plague Ogryn every single time, but that's boring. So I'm just gonna write I can write Plague Ogryn as my target, but that would be boring. So I'm just gonna do pick a random character in the list of enemies. Okay, and after that has happened, after every character attacks, display stats so that we know what's going on, because one of these might have regenerated some health by resetting, and you know, I want the updated stats. Okay, cool. Then I'm going to print this again, and I realized that this is wasteful, that I could probably turn this into a function. But again, MVP, and I like to write code. I like to write my first iteration of code to be very, very readable. It may be long, it may be long-winded, but as long as it's very readable, I can condense it and make it more succinct. But until then, until I'm ready to do that, I prefer to write the same thing multiple times, and then eventually I will use things like comprehension. I will use better functions or inbuilt functions, whatever the case may be. Now it's time for the enemies to attack, and all I'm doing is swapping around the wording. Okay, and then I want to again check. Okay, last but not least, I need the game to check whether everyone has 0 AP. So I've written here AP 0 equals all, and then character dot AP equals 0. So this is a sort of truthy or falsy kind of statement. So what I've done is the character in ally plus enemy. So what I've effectively done is, like, I've kind of zipped the two lists together. So the ally list and the enemy list, and I'm focusing on only their APs. So I've taken their APs in both lists and sort of zipped them together, right? And if it so happens that every single character in this list has an AP of 0, then the game will decide to refresh everyone's AP and moved around forward. So if AP dot underscore 0 equals true, so if this happens to be true because of this Boolean statement, most of the time it will be false, but when everyone has spent all the actions, it will be true. So if that is true, then for character in ally plus enemy, it should be character dot reset AP. Okay, and reset, I don't need to print anything because reset AP already comes with its own print statement, refreshing action points. And then I progress the round. So round plus equals 1, and then print next round. Wow, okay. Now what I'm going to do now is that I'm going to run everything again, make sure I get no errors. Okay, and run the game. So in round 1, we start off with, so this is the first entry is the Sharpshooter, the second entry is the Preacher, the third entry is the Plague Ogryn, and the fourth entry is the Dreg. So Rogue chose ranged attack, and he attacked the Dreg Gunner for 40 points of damage, right? Current Rogue stats. And you can see that his action points have gone down by 1 because everyone starts with 3. Scourge chose ranged attack, and he attacked Dreg Gunner for 51 points of damage. So now, after the allies have attacked, here's what the stats look like for everyone. Everyone's health and damage is the same, whatever, but the Dreg is hurting, right? He's gone from 200 health to 109 health. Cool. Plague Ogryn decides to get some payback and melee attack Scourge for 105 points of damage. Now, Scourge's toughness was 100, so that means he took 100 damage. 10% of that went to his health, and the rest of the 5 HP also would go to his health. So the Dread Gunner attacked Rogue for 64 points of damage. That only ranged attack, so that's a ranged attack, so that just hits the toughness. So if we look at Scourge's health, we can clearly see that he's lost only 5 HP, which is not what it's supposed to be. So eventually I need to come back and redo some of this calculation. I need to redo some of this calculation because he ate through the toughness, which I need to basically I need to redo this calculation, because what that says here is that he's eaten through the toughness, received no health damage, and then only that last 5 HP went to the health, which is not what this is suggesting. So perhaps I just need to change this to 1, right? So that if you have maximum toughness, you get maximum damage mitigation on your health, and you only take toughness damage. But if you are less than max toughness, then you start taking health damage as well as taking toughness damage. So again, MVP, that's more complex than what I've done here. So back to where we're at. So the allies are still not really hurting, but the Dread Gunner gets completely rolled. So that's Rogue high rolled on his volley fire, and it was able to fire 5 times. So 60, 80, and then 80 plus 80, 160. So the Dread Gunner's dead. So it should end right now. Yeah, and game over. Cool. Right? Because the Dread Gunner died. If I did this all over again, then something else might happen. So instead we go to round 2, so we can clearly see that no one died in round 1. Everyone just attacked different people, and maybe they low rolled, right? So at the end of round 1, Rogue has 98 shield, 66 HP. Scourge is sitting pretty. The Plague Ogryn is hurting a little bit. He's lost almost 200 HP. Dread Gunner's alright, he's lost about 50 HP. Cool. Alright, going into the next round. And you can clearly see that, blue refreshing action points. Going into the next round, went into round 3. So at the end of round 2, the Dread Gunner is almost dead. But both Rogue and Scourge are really, really healthy right now. The Plague Ogryn's really hurting. He's lost over 300 HP. Alright, round 3. Rogue high rolled and literally just shot the Dread Gunner to bits, right? So volley fire high rolled for 4, and he's doing all this damage, and someone died. Game over. Alright, I hope this tutorial, it wasn't as short as I wanted it to be, so I'll probably break it into parts. I hope you enjoyed this tutorial. Let me know if you have any questions. Let me know if you want the code. I will put it up on a GitHub somewhere so that everyone can play with it. And yeah, I hope this video was very helpful. See you on the next one.